Hello everyone and welcome to the IE 503 Operations Analysis Group Assignment. I am Omkar and I would start. Following me would be Yogendra and Vedant. Our topic for the assignment is quality management, quality assurance and sampling. So let's start. Before going into quality management and other subparts, let's have a short introduction to quality. Quality is extremely hard to define and it is simply stated fit for the use or purpose. It is all about meeting the needs and expectations of customers with respect to functionality, design, reliability, durability, and price of the product. Quality is completely described with respect to customers. It should meet the ends and expectation of customer. If a product or service meets all those needs, then it has passed the quality test. If it doesn't, then it is substandard. Now let us see what actually does quality management means. Quality management is the act of overseeing all the activities and tasks that must be accomplished to maintain a desired level of excellence. This includes the determination of quality policy, creating and implementing quality planning and assurance, and quality controls and quality improvements. It is also referred as Total Quality Management, also known as TQM. Now let us see on the principles of quality management. There are 7 principles. Let's start with the first, customer focus. The primary focus of quality management is to meet customers' requirements and to strive to exceed customers' expectations. Second, leadership. Leaders at all levels establish unity of purpose and directions and create conditions in which people are engaged in achieving the quality objectives of the organization. Third, engagement of people. It is essential for the organization that all people are capable and empowered and engaged in delivering values. Capable, empowered, and engaged people throughout the organization enhance its capability to create value. Fourth, process approach. Consistent and predictable results are achieved more effectively and efficiently when activities are understood and managed as interrelated processes that function as a coherent system. Fifth, improvement. Successful organizations always have an ongoing focus on improvement. Sixth, evidence-based decision making. Decisions based on the analysis and evaluation of data and information are more likely to produce desired results. Seventh, relationship management. For sustained success, organizations manage their relationships with interested parties such as suppliers. Now let us see how do we actually manage quality. It is done in 3 steps. Plan quality, perform quality assurance, and then perform quality control. Let's see them one by one. Plan quality. The plan quality is the process of identifying quality requirements and or standards for the projects and its deliverables and documenting how the project will demonstrate compliance with respect to relevant quality requirements. The input to this system includes scope baseline, stakeholder registers, cost performance baseline, schedule baseline, risk registers, enterprise environmental factors, organizational process assets. Various tools and techniques are used to understand this. This includes cost benefit analysis, cost of quality, control charts, benchmarking, design of experiments, statistical sampling, flow charting, and various others. Output to this includes quality management plan, quality metrics, quality checklists, process improvement plans, and project documents are also updated. Let us see one of the most important tools, cost of quality. Cost of quality is defined as a methodology that allows an organization to determine the extent to which its resources are used for activities that prevent poor quality, that appraise the quality of the organization's product or services, and that results from internal and external failures. Cost of quality evaluates the cost of conformers with the cost of non-conformers to reach a balance. Cost of conformers includes quality training, studies, and service. Cost of non-conformance includes rework, scrap, inventory cost, and warranty cost. Deming says that 85% of cost of quality is a direct responsibility of management. Yogendra will add on quality assurance.
Now we will see what is quality assurance. Quality assurance includes all the activities related to satisfying the relevant quality standards for a project. Another goal of quality assurance is continuous quality improvement. Benchmarking can be used to generate ideas for quality improvements, and quality audits help identify lessons learned that can improve performance on current or future projects. Now we will see how to perform quality assurance. While doing quality assurance, we use several tools and techniques, such as plan quality and perform quality control tools and techniques, then quality audits and process analysis. While doing quality assurance, we need some inputs that are project management plan, quality metrics, work performance information, and quality control measurements. Now it produces some outputs that are organizational process asset updates, change requests, project management plan updates, and project document updates. Now we will try to understand quality assurance with an example of a software firm which tries to assure quality for its product. Quality assurance has a defined cycle called PDCA cycle or Deming cycle. The phases of the cycle are plan, do, check, and act. These steps are repeated to ensure that processes involved in the organization are evaluated and improved on a periodic basis. Let's look into the above steps in details. Plan. Organization should plan and establish the process related objectives and determine the processes that are required to deliver high quality end products. Then do. Development and testing of processes and also do changes in the processes. Then we have check. Monitoring of processes, modify the processes and check whether it meets the predetermined or objectives. Then act. Implement actions that are necessary to achieve improvements in the processes. Now we will try to understand some best practices used for quality assurance. Create a robust testing environment. Apply automated testing to high risk areas to save money. It helps to fasten the entire process. Then allocate time appropriately for each process. It is important to prioritize bugs fixes based on software usage. Form dedicated security and performance testing team. Simulate customer accounts similar to a production environment. Now we will look at some of the quality assurance functions. Number one is technology transfer. This function involves getting a product design document as well as trial and error data and its evaluation. The documents are distributed, checked and approved. Then we have validation. Here validated master plan for the entire system is prepared. Approval of the test criteria for validating product and process is set. Resource planning for execution of a validation plan is done. Then we have documentation. This function controls the distribution and archiving of documents. Any change in a document is made by adopting the proper change control procedure, and approval of all types of documents is done. Then assuring quality of products and quality improvement plans. Now we will look at quality assurance certifications. There are several certifications available in the industry to ensure that organizations follow standard quality processes. Customers make this as a qualifying criteria while selecting a software vendor. Let's know about ISO 9000. This standard was established in 1987 and it is related to quality management system. This helps the organization ensure quality to their customers and other stakeholders. An organization who wishes to be certified as a ISO 9000 is audited based on their functions, products, services, and their processes. The main objective is to review and verify whether the organization is following the process as expected and check whether existing processes need any improvement. This certification helps organization in many ways. Let us look at that. Increase the profit of the organization, then improves domestic and international trade. It also reduces waste and increases the productivity of the employees. It also provides excellent customer satisfaction. Now, We have various types of models for quality assurance. Let us look at some of them. The first one we are looking at is Capability Maturity Model Integrated, which is known as CMMI. It has 5 levels. The level 1 is initial. In this stage, the quality environment is unstable. Simply no process has been followed or documented. Level 2 is managed. Some processes are followed which are repeatable. This level ensures processes are followed at the project level. Level 3, that is defined. Set of processes are defined and documented at the organizational level. Those defined processes are subject to some degree of improvement. Then we have quantitatively managed. This level uses process metrics and effectively controls the processes that are followed. Then we have optimizing. This level focuses on continuous improvement of the processes through learning and innovation. So now we will look at the second one, that is test maturity model. This model assesses the maturity of processes in a testing environment. Even this model has 5 levels defined below. Level 1, initialization. There is no quality standard followed for testing processes and only ad hoc methods are used at this level. Then definition. Defined processes, preparation of test strategy, plans, test cases are done. Then integration. Testing is carried out throughout the software development lifecycle, that is SDLC, which is nothing but integration with the development activities, example V model. Then level 4, management and measurement. Review of requirements designs takes place at this level and criteria has been set for each level of testing. The next one is level 5, that is optimization. Many preventive techniques are used for testing processes and tool support with automation is used to improve the testing standards and processes. Now for conclusion, I would like to say quality assurance is to check whether the product developed is fit for use. For that, organization should have processes and standards to be followed which need to be improved on a periodic basis. It concentrates mainly on the quality of product or service that we are providing to the customers during or after implementation.
Now let us see about quality control. Quality control is a process through which a business seeks to ensure that products' quality is maintained or improved. Quality control requires that the business to create an environment in which both management and employees strive to perfection. The input to this system includes project management plan, quality metrics, quality checklists, work performance measurements, approved change requests, deliverables, organization's process assets. Tools and techniques to this includes cost effect diagram, control charts, flow charting, histogram, Pareto chart, run chart, scatter diagram, and various other things. Output to this includes quality control measurement, validated changes, validated deliverables, organizational process assets are updated, change requests, project management plans are updated, and also project documents are also updated. Let us see one of the important tool, Pareto chart. Pareto chart is a graph that indicates the frequency of defects as well as their cumulative impact. Pareto charts are useful to find the defects to prioritize in order to observe the greatest overall improvement. The Pareto principle states that for many outcomes, roughly 80% of the consequences come from 20% of the cause. Now let us see about control chart. Control chart is a graph used to study how a process changes over the time. The data are plotted in time order. A control chart always has a center line for the average, upper line for the upper control limit, and the lower line for the lower control limit. These lines are determined from the historical data. When to use a control chart? When controlling ongoing process by finding and correcting problems as they occur. When predicting the expected range of outcomes from a process. When determining whether a process is stable or not. When analyzing patterns of process, variations from the special causes or some common causes. When determining whether your quality improvement project should aim to prevent specific problems or to make fundamental changes to the process. Correct control chart selection is an critical part of selecting a control chart. If a wrong control chart is selected, the control limits will not be correct for the data. The types of control chart required are determined by the types of data to be plotted and format in which it is collected. Data collected is either in variables or attribute format, and the amount of data contained in each sample collected is specified. This algorithm is used to select what type of control chart should be used. If there are variables data, then let us see are the subgroup present. If the subgroup size is 1, then we use XMR chart, otherwise use XR charts. And if there are no variables data, then we see the condition, can the data being collected be larger than the subgroups? If yes, again we see equal size subgroup. If that is also yes, use O chart or U chart. If no, then we use just the O charts. And if this condition is not satisfied, then we use, and then again we see are there equal size groups. If they are yes, then use NP chart or P chart, or otherwise just use the P chart. Vedant will continue from here for sampling.
The purpose of quality control is to make sure that processes are performing in an acceptable manner and that the quality of inputs are acceptable. This may be accomplished by monitoring process output using statistical techniques. Sampling in quality control can thus be used for quality assurance. But what is meant by sampling? Sampling allows an auditor or a researcher to study a group, example a batch of products, by observing only a part of that group and to reach conclusions with a predefined level of certainty. Now, what is the need for sampling? So, sampling is frequently used because gathering data on every member of a target population or every product produced by a company is often impossible, impractical, time consuming, and may not be economically feasible. Now we will talk about the types of sampling. So first is random sampling. In a random sample, all units or parts have the same likelihood of being selected for inspection. A sample chosen randomly is meant to be an unbiased representation of the total population. But there are some problems associated with random sampling, like how does one decide how many pieces to pick for his inspection? How does one decide what number of defective units is too many? And how certain is he to make the right decision since it is based on his findings on a random sample? Keeping these questions in mind, let's move on to statistical sampling. This is the most popular plan that was developed by the US Department of Defense. Many people call it an AQL inspection. AQL stands for Acceptance Quality Limit and is defined as the quality level that is the worst tolerable in ISO 2859-1 standards. AQL 1% means that not more than 1% defective items in the whole order quantity is acceptable. It represents the maximum number of defective units beyond which a batch is rejected. Importers usually set different AQLs for critical, major, and minor defects. Most Asian exporters are familiar with this type of setting. First, let us understand about this classification of defects. In practice, three types of defects are there. First is critical defects. Critical defects are those which are totally unacceptable as a user might get harmed or regulations are not respected. Then there is major defects. The product with major defects would not be usually considered acceptable by the end user. Then there is minor defects. Minor defects are those in which there is some departure from specifications, but most users would not mind. Let's understand how this kind of sampling is done with an example. So, a chair manufacturing factory manufactures 40,000 chairs in one batch. What should be the sample size that should be chosen for quality check? Then what should be the maximum number of defective chairs after which the whole batch is rejected? Also, this sampling is to be done by the method of single sampling plan with level 2 normal severity. The AQLs that both the buyer and supplier agree on are as follows: 0% critical defects, 1.5% major defects, and 4% minor defects. These questions can be answered by AQL tables. They are the statistical tools for product inspections. They are an industry standard. Now, first table contains the sample size code letters. So here is the range of lot size, and on the top is given the level of inspections. According to our question, the lot size is 40,000, which falls under this range, and the inspection level is 2. So we get the code letter N. Now, second table contains the sampling and acceptance limits. So here each letter is associated with the number of samples, and on the top is given the percentage of defects. The quantity written in green is the acceptable quantity. Suppose, according to our question, there should be 0% critical defects, which means that 0 is our acceptance quantity. If we found one critical defect, then the whole sample, whole batch would be rejected. Similarly, there should be only 1.5% major defects, which lead us to 14 as the acceptable quantity. This means if we found 15 products with major defects, then the whole batch would be rejected. Then there is 4% minor defects, in which 21 is the acceptable quantity, which tells us that if we found 22 products with minor defects, then the whole batch would be rejected. So in conclusion, your code letter is N, so you will have to draw 500 pieces randomly. Then here are the limits. The products are accepted if no critical defects and no more than 14 major defects and no more than 21 minor defects are found. Then there are some other types of sampling as well, such as double sampling plan, which is used when the acceptable quantity cannot be found with the help of a single sample. Then there is continuous sampling, which is used while making nylon threads and chocolate bars. Then there is acceptance on zero sampling. So some importers who are sensitive to legal litigation by their customers or who have high quality standards accept batches only if no defective unit is found. So this is common in industries such as automotive or pharmaceutical. Then there is sampling by variables, in which we classify the sample on the basis of the variables such as product length.